Welcome to another exciting class on differentiation. So today we're actually going to show you the shortcut. Remember last class we talked about differentiating from first principles, it was called, where we did the limit as h approaches 0 of f of x plus h minus f of x over h. And they were really quite time-consuming little questions. However, we don't do it like that normally. That's the old-fashioned way of doing it. We have shortcuts. So there are many rules to learn. And you must understand the differences between when you do and don't use a rule. And the best way to do that is to do lots of questions. So let's get into some of our language first. First of all, the derivative, which is m, or y dash, or dy over dx, or f dash x. The derivative of something gives you the gradient, or the slope, at a particular point, the gradient of the tangent. Now, if we have y equals something with x's in it and x is raised to a power, the derivative is found by taking the power and timesing it out the front and then decreasing the power by 1. So here's an example that would line up with this. If I had y equals 2x to the power of, say, 8, dy over dx would equal, looking at this, n is now the power 8. So I take the 8 and I times it to the 2 out the front. And that's where nk is. So I times it to the 2 out the front. 8 times 2 is 16. I put the x and decrease the power by 1. That's the derivative. That's the rule that will allow me to find the gradient. Let's try it with some questions now. Differentiate the following. So for the first one, I'm going to say, well, I'm finding the derivative, so I'm going to call it y dash this time. Remember, I could have called it y dash, I could have called it dy over dx, I could have called it f dash x, although you tend not to use f dash x unless the question has an f of x in it. If it starts with a y, you use one of these two. If it starts with an f of x, you use that one there, and they are all abbreviations for the derivative is equal to, or the derivative is. So the derivative is equal to, let's go back to part A. We take the power, we put it out the front. So 5 out the front of the x, there was just a 1 there, because it's 1x to the power of 5. So you get 5 lots of 1, or 5. X to the power of the new power is 1 less than the original one. Finished. Let's go to part B. The derivative equals, look at the power is 4. 4 times a 3 out the front gives 12. Rewrite the x, the new power is 1 less than the original power. Finished. That is the derivative, or the rule that will allow you to find the gradient. Question, or part C. The derivative equals. Now you'll notice with this, I've got plus and minus, plus, plus. That means do each part as an individual question. There's 1, 2, 3, 4, 5 individual calculations we have to do here. Looking at the 2x to the power of 6 part first. 6 times 2 is 12. X, the new power is 1 less. There's your answer for that part. Plus, now let's do the next part as another question. X to the power of 4 times the 4 at the front, you get 4x. My new power becomes 1 less than 4, which is 3. Minus, let's do the next part as another question. The power is 2. 2 goes out the front, 2 times 3 is 6. X to the power of, my new power becomes 1 less than the original, 1 less than 2 is 1, so it's 6x to the power of 1. I'm not going to write to the power of 1, I'll just leave it as 6x. When you look at the next part, you need to recognize that it's actually 5x to the power of 1. And so if you take that power, which is 1, and times it out the front, you get 5. And then you get x to the power of nothing, and anything to the power of nothing is 1. So the x part drops out. That is your derivative. When you differentiate 2, think of it as 2x to the power of nothing. There's no x parts, and if you take that 0 and times it to the 2 out the front, you get nothing. So there is your derivative, that big expression. When you get to 1 part D, for the moment, the only way we know how to do this is to expand the bracket. Now you could write it out like this and FOIL it all out, or you could look at it and use your smiley face technique. So 2x, when you square it. 2x times 2x is 4x squared. Multiply the two terms together. 2x times 1 is 2x, and double it and you get 4x. The last term is 1. 1 times 1 is 1. So that is what we're trying to differentiate. Notice I haven't put y dash, I've just put y. Because I'm not differentiating, I'm just expanding brackets. Now I'm going to differentiate. So we look at the power above the x, it's a 2. 2 gets times to the 4 out the front to give me 8. X to the power of my new power is 1. Plus 4x, x has a 1 above it, so 1 times 4 is 4. X to the power of nothing, which that means the x's drop out. When you differentiate the number 1, it's gone. The numbers never always give 0. That's your answer. The derivative is equal to 8x plus 4. So let's look at this question. It's asking us to find, we've got f of x is equal to something, and it's asking us to find f dash 2, the derivative when x equals 2. You'll remember in the earlier exercises, first exercise we did, we had some graphs and we drew tangents on. If you drew a tangent when x was equal to 2 and found the gradient of that tangent, that's what f dash 2 is, the gradient of the tangent. We also have to find something else a bit later, and we'll deal with that in a moment. But let's first of all find f of x. So f dash x, sorry, not f of x, f dash x. Looking at the first term, it's an x cubed. So I'm looking at the first term here, x cubed. The power is 3. So 3 goes out the front. And my new power will be 1 less than the original. Plus, the next term is 2x squared. The power is 2. So the power multiplies to the number at the front. 2 times 2 is 4. My new power is 1 less than the original, so it's 1. Minus. When I look at the 4x term, the power above the x is a 1. 1 times 4 is 4, and you get x to the power of nothing for your new x term. The plus 1, when you differentiate it, drops out. What I'm interested in is what's the derivative when x is 2? So everywhere I see x, I put a 2 in its place. And if you do that, let's see, 2 squared is 4, 4 3s are 12, 12 plus 8 is 20, 20, whoops, take 4 is 16. So, the gradient of this curve at x equals 2 is 16. Example number 3. So let's have a look and see what's going on with example 3. First one says, find the equation of and angle of inclination of the tangent at a 0, 1. Okay, so to find the equation of the tangent, I need to find the equation of a line. To find the equation of a line, I'm going to need to know the derivative. Now, with this particular question, I'm going to go f of x equals, I'm going to have to expand it out, x plus 3 in brackets, x plus 3 in brackets becomes x squared plus 6x plus 9 if I expand it out, which means the derivative equals x squared, the power is 2, so 2 goes out the front, the new power is 1, so it's 2x, plus 6x to the 1 times is to the 6, 6x to the nothing. That's the derivative there, because the plus 9, when you differentiate a number, it just disappears. So that's the derivative. Now, I'm actually interested at the point 0, 1. X is 0 there, which means I want to find the gradient when x is 0. So f dash 0 equals 2 times 0 plus 6, which is 6. So that means the gradient is 6. So I can find the equation of the tangent using this formula here. So it becomes y take 6 equals the, let's take that back. Y take y1, y take 1 because there's x1, there's y1. So y take 1 equals the gradient, which is 6 bracket x take 0, because x1 is 0. And if I expand the right hand side out, I just get 6x. I'll move the plus 1 across. That is the equation of my tangent. Or I could write it as 6x take y plus 1 equals 0 if I wanted it in general form. So that's the equation of the tangent at 0, 1. Also wants the angle of inclination. The angle of inclination is a little bit different. Remember, to find the angle, I can use m equals tan theta. Well, I know at this point the gradient is 6. So 6 equals tan theta. Theta equals the inverse tan of 6, which is going to equal, get on my calculator and go the inverse tan of 6, and I get an answer of 80.5 if I just take it to one decimal place. So it's 80.5 degrees. That's a very steep line. Right, let's go to part B. Find the gradient and the angle of inclination of the normal at A. Well, at A, we know the gradient is 6. So we know back here the gradient at A was equal to 6. What would the gradient of the normal be? Well, the normal, perpendicular lines are normal to each other. It's 90 degrees. So the gradient I'm interested in for this particular question is gradient equals not 6 over 1, but 1 over 6. And I need to put a minus sign in front of it. I know it's passing through 0, 1 still because that's the point A. So let's find the gradient and the angle of inclination of the normal at A. And then draw a sketch. Well, if the gradient is minus 6, that means tan theta equals minus 1 on 6. I think I said minus 6. The gradient is minus 1 on 6. Get on your calculator and type in the inverse tan of minus 1 over 6, and you will get minus 9.5 degrees. What does that actually mean? We draw a sketch of it. We know it goes through the point 0, 1, which is there. And we know that it has a gradient of minus 9.5 degrees. So the line actually goes like this. And that angle there is 9.5 degrees. Because when you see a negative angle, it gives you the angle on the left side of a line when you're talking about gradients. And if it's positive angle, it's on the positive side. So it's always up on the upper side of the x-axis, positive angle, negative angle. So there's my sketch of the normal at A. Part C says, find the x-intercepts of the tangent and the normal by finding their equations. Well, for the tangent, I know its equation. The tangent was y equals 6x plus 1. We found that. How do you find an x-intercept? You let y equal 0. So the x-intercept is from letting y equal 0. And if I let y equal 0, I get 0 equals 6x plus 1. Minus 1 to both sides, and then divide by 6, and I'll get x equals minus 1/6. If I talk about the normal, I actually do know its equation as well. It's y equals, the gradient was minus 1 on 6x plus 1, because it went through 0, 1, and that's the y-intercept. The x-intercept is found when y equals 0. If I let y equal 0, I get 0 equals minus 1 over 6x plus 1. I'll plus the 1 over 6 to the other side, times both sides by 6, and there's my answer. So the x-intercept is 6. So if I actually go back over to this graph, what it's saying is that's at 6, and that we know is at 0, 1. Now, find the area of the triangle formed by the tangent, the normal, and the x-axis. The tangent, the normal, and the x-axis. Well, let's just do a quick sketch again of what's going on here. There is my normal. Here's the tangent one. I haven't drawn the function, but this comes from here. That's y equals 6x plus 1. This one is y equals minus 1/6 x plus 1. We know they meet up as high as 1. We know that there is at 6. This one here is at minus 1/6. And I know that because the x-intercept of that line is minus 1/6. Now, to find the area of a triangle. Area of a triangle is equal to half base times height, which equals a half. Now, the base is the distance all the way across the triangle, which will be from 0, 0, it's 6 units out. From 0, 0, it's 1/6 units back. It's 6 and 1/6 units. So it's times 6 and 1/6 times. Now the height is the distance from 0, 1 there down, perpendicular distance, which is just 1 unit. So we do a half times 6 and 1/6. So you put that into your calculator, and when you put that into the calculator, you'll end up with 37 over 12, or 3 1/12. And that will be units squared. That's the area of the triangle. Quite a challenging little question, that one. All right, time for you to start getting into it and trying to do some questions. Best of luck. Bye for now.